Have you ever paused, looked up at the night sky, and wondered what it would be like to stand on another planet? To feel the ground beneath your feet, a world entirely different from our own, the allure of the unknown, the challenge of exploration, it all begins with that simple question. Imagine stepping out of your spaceship, the culmination of years of training and preparation, onto the dusty red ground of Mars. The first footprint, a symbol of humanity's reach extending beyond Earth. You look up at a pale pink sky, a constant reminder of the alien world you now inhabit. Earth, a distant blue dot, a nostalgic beacon in the vast expanse. What if, overcome with curiosity, or perhaps a moment of reckless abandon, you took off your helmet and tried to breathe? What would happen? The answer, stark and unforgiving, reveals just how unique and precious Earth is. A haven, perfectly balanced to support life as we know it. On most planets, the air is either too thin, offering virtually no resistance to the harsh vacuum of space, too thick, a crushing weight that would instantly obliterate any unprotected visitor, or perhaps most commonly made of the wrong gases, a cocktail of toxic elements that would be instantly fatal for us to survive. Here on Earth we breathe a life-giving mix of gases, a delicate balance honed over millennia. This mixture is mainly oxygen, that our bodies need to function, to thrive, to simply exist. On Venus, the air is a completely different story. It's mostly carbon dioxide, a suffocating blanket around the planet. The atmosphere is thick and crushing, with no oxygen at all, making it impossible for humans to survive without specialized equipment. The pressure and heat would overwhelm you instantly, a testament to the planet's incredibly hostile environment. Mars is different, a seemingly more approachable world but just as deadly in its own way. Its atmosphere is extremely thin, offering little protection from radiation, and made almost entirely of carbon dioxide, rendering it unbreathable. If you took off your helmet on Mars, the lack of air pressure, the intense radiation and the freezing cold would be fatal in a matter of moments. Mars may look like a desert, with its familiar red hues, but its atmosphere is completely alien and hostile, a stark reminder of the challenges of interplanetary colonization. So what exactly is an atmosphere? It's a layer of gases that surrounds a planet, held in place by gravity. This layer acts like an invisible blanket, regulating temperature and influencing weather patterns. It can keep a planet warm by trapping heat, shield it from harmful radiation from the sun, and, crucially, provide air to breathe, the very essence of life. Each planet's atmosphere is unique. Some are incredibly thick, dense with gases and swirling clouds. Some are thin and wispy, barely clinging to the planet's surface. And some are almost non-existent, leaving the planet exposed and vulnerable to the harsh realities of space. By exploring and understanding these diverse atmospheres, we can begin to unravel the mysteries of planetary evolution and learn why life thrives so uniquely on Earth. This knowledge is crucial as we continue our search for habitable planets beyond our solar system, helping us to identify what to look for on other worlds. So, let's begin our tour of the solar system and discover what the air, or lack thereof, is like across these fascinating and diverse worlds. Ready to take a deep breath of discovery and explore the atmospheres of our solar system? Let's begin. Our first stop on this cosmic journey is Mercury, the closest planet to the Sun. It's a world that presents some truly unique challenges and contrasts to what we're familiar with here on Earth. We're going to delve into what makes Mercury such an intriguing yet incredibly difficult place to survive. Mercury is a world of extremes, a place where the very definition of habitable is stretched to its breaking point. Scorching days where temperatures can soar to hundreds of degrees Celsius, hot enough to melt some metals. Freezing nights where the thermometer plummets to hundreds of degrees below zero. This drastic temperature swing is one of the many reasons why Mercury is such a challenging environment, but it doesn't have a real atmosphere to regulate these temperatures, or to protect the surface. Instead, it has just a super thin exosphere, a tenuous layer of gases that barely qualifies as an atmosphere at all. This exosphere is made of scattered atoms blasted off the surface by the relentless solar wind, the constant stream of particles emanating from our sun. There's no air to breathe, meaning no possibility of sustaining life as we understand it without advanced technology, and there's no protection from the sun's deadly radiation, which constantly bombards the surface, making it a hazardous place for any unprotected organism. The sky is pitch black, even during the day, because there's no atmosphere to scatter sunlight and create the familiar blue hue we see on Earth. And the silence is absolute, broken only by the faint hum of your own life support systems, a constant reminder of your dependence on technology. Mercury's exosphere is constantly being stripped away by the solar wind, only to be replenished by new atoms ejected from the surface. It's a dynamic, ongoing process. Without an atmosphere, Mercury is completely exposed to the harshness of space, vulnerable to micrometeoroid impacts and the full force of solar flares. Surviving here would require technology far beyond what we currently use, even for spacewalks outside the International Space Station. You'd need a specialized suit to protect you from the extreme heat, the bitter cold, and the constant bombardment of radiation, a technological marvel in itself. And of course, the suit would need to provide every single breath, recycling air and maintaining a stable pressure in the vacuum of space. Mercury reminds us that being close to the sun doesn't automatically mean a planet is warm, habitable, or welcoming. Proximity isn't everything. Without an atmospheric blanket to trap heat and shield against radiation, life as we know it is simply impossible on the surface of Mercury. Mercury is a stark, silent world, a place of desolate beauty, but utterly inhospitable to unprotected life, a testament to the power of a planet's atmosphere. Next, we visit Venus, Earth's so-called twin, but only in size. Venus is wrapped in a thick, toxic atmosphere that traps heat, making it the hottest planet. The pressure on Venus is crushing over 90 times greater than Earth's. Its air is almost pure carbon dioxide with clouds of corrosive sulfuric acid. The sky glows yellow-orange and the surface is hot enough to melt metal. Spacecraft survive only hours before being destroyed by the heat and pressure. Venus is a warning of what happens when the greenhouse effect runs wild. No suit could protect you here, you'd be crushed, cooked, and dissolved in moments. Venus is a beautiful planet from afar, but up close, it's a deadly inferno. Venus shows us how a planet so similar to Earth can become utterly uninhabitable. Now let's return to Earth, our perfect home. Earth's atmosphere is a balanced mix, mostly nitrogen, with just enough oxygen for life. This multi-layered blanket shields us from harmful radiation and burning meteors. The ozone layer absorbs dangerous ultraviolet rays, protecting all living things. Our atmosphere keeps temperatures stable, trapping just enough heat for water to stay liquid. It creates climates from tropical forests to polar ice, but always supports life. The blue sky is a daily reminder of our protective air. Earth's atmosphere is rare and precious, a life support system we must protect. No other planet offers such a perfect balance. Understanding this helps us appreciate and safeguard our fragile bubble. Earth is the only world we know where we can breathe easy. Our atmosphere is what makes Earth home. Next up is Mars, the red planet. Mars looks like a cold desert Earth, but its atmosphere is a different story. The air is 100 times thinner than Earth's and made almost entirely of carbon dioxide. There's barely any oxygen, and the pressure is so low you'd need a spacesuit just to survive. Mars can be warm at noon, but at night temperatures plunge far below freezing. The thin air offers little protection from radiation or meteors. Any future explorers will need pressurized habitats and constant protection. Mars is fascinating, but its thin, cold atmosphere is a constant challenge. Mars may look familiar, but it's a world where every breath must be brought from home. Now, prepare to journey far beyond the rocky inner planets as we set our sights on the realm of the gas giants. Colossal spheres of swirling gas and mystery. These behemoths dominate the outer solar system, offering a stark contrast to the terrestrial worlds we've explored thus far. We're talking about Jupiter and Saturn, the undisputed kings of the gas giants. These planets are not just large, they are absolutely immense, dwarfing Earth and the other rocky planets in both size and mass. Unlike Earth, these planets have no solid surface to speak of. Forget about landing, there's no ground beneath the swirling clouds. Instead, they consist of deep, swirling atmospheres composed primarily of hydrogen and helium, the same elements that fuel our sun. These gases are in constant motion, creating dynamic and ever-changing weather patterns. Jupiter's storms are legendary, and none is more famous than the Great Red Spot. This colossal storm is so vast that it's larger than Earth itself, a swirling vortex of crimson clouds that has persisted for centuries. In fact, this monstrous weather phenomenon has raged for at least 3 centuries, possibly even longer, a testament to the immense power contained within Jupiter's atmosphere. Meanwhile, Saturn's atmosphere presents a different kind of beauty, striped with jet streams that create distinct bands of color and texture. And at Saturn's North Pole, a truly bizarre feature exists, a massive hexagonal storm, a geometric marvel that defies easy explanation. Both planets are characterized by incredibly violent winds and atmospheric pressures that would be instantly fatal to any unprotected human. The immense pressure at the depths of these atmospheres would crush any spacecraft, turning metal into scrap in an instant. The deeper you descend into these gaseous layers, the hotter and denser the environment becomes, a relentless increase in temperature and pressure. There's simply nowhere to land, no breathable air, just an endless expanse of atmosphere stretching down into the unknown. Their vibrant and colorful clouds are composed of ammonia, methane, and other exotic chemicals, creating stunning and mesmerizing views when observed from afar, a testament to the beauty that can exist even in the most hostile environments. But for humans, these worlds are essentially impossible to visit, at least with our current technology. The challenges are simply too great. The gas giants are undeniably majestic, awe-inspiring in their scale and beauty, but they are also utterly alien, fundamentally different from anything we experience on Earth. No life as we know it could possibly survive in such extreme conditions, where the very laws of physics seem to operate differently. The crushing pressures and violent storms of their deep atmospheres make them inhospitable to any known form of terrestrial life. They serve as a constant reminder of just how diverse and varied planets can be, and how different they can be from our own familiar world. The gas giants are wonders to observe from a safe distance, offering breathtaking views and fueling our imaginations, but they are certainly not places to visit anytime soon. Farther out we find Uranus and Neptune, the ice giants. These planets are blue because of methane in their atmospheres, which absorbs red light. They have no solid surface, just frigid, windy layers of gas and ice. Uranus is tilted on its side, causing extreme seasons. Neptune has the fastest winds in the solar system, reaching over 2,000 kilometers per hour. Temperatures here are among the coldest anywhere, dipping below minus 220 degrees Celsius. The pressure would crush anything that tried to descend. These worlds are beautiful but brutally inhospitable. They remain mysterious, distant giants, fascinating, but forever out of reach. The ice giants are cold, windy, and utterly alien. Planets aren't the only worlds with atmospheres, some moons have them too. Saturn's moon Titan has a thick, nitrogen-rich atmosphere, denser than Earth's. The sky is orange, and sunlight is dim like permanent twilight. Titan's weather is based on methane, not water. It rains liquid methane, forming rivers and lakes. Other moons, like Jupiter's Io and Europa, have thin atmospheres or exospheres. Europa may even hide a vast ocean beneath its icy shell with hints of oxygen in its thin air. These moons show that atmospheres can exist in surprising places. Titan and Europa are top targets in the search for life beyond Earth. Even small worlds can have complex, intriguing environments. The moons of our solar system expand our imagination of where life might exist. Our tour has revealed atmospheres from Mercury's emptiness to Venus's inferno and Neptune's icy winds. To support life, a planet needs just the right atmosphere, right pressure, right gases, and protection from radiation. Earth is unique. Its atmosphere is a rare, delicate balance that makes life possible. Now, astronomers are searching for exoplanets with similar atmospheres. Using powerful telescopes, we can study the light passing through distant worlds' air, searching for signs of life. The ultimate goal: find another planet with a breathable atmosphere. Every discovery brings us closer to answering, are we alone? Our fragile bubble of air is a rare treasure in the universe. The search for another Earth is really a search for another breath of life.